All right, let's jump right in. If you've spent any time at all in the world of computer science, you've heard two words thrown around constantly: algorithm and program. Now, they sound pretty similar, right? And honestly, a lot of people use them like they mean the same thing, but they are fundamentally different. And getting this difference isn't just about passing a test, it's the absolute key to understanding how we tell computers what to do. But before we get into the weeds, let me ask you a question. Seriously, would you ever try to build a house without a blueprint? Just start buying bricks, mixing cement, and hoping for the best? Of course not. You'd end up with a total disaster. That simple idea right there is the perfect way to understand everything we're going to talk about today. So keep that image in your head: the blueprint versus the house. So let's start with that plan. Before a single brick is laid, before a single line of code is written, you have the idea, the strategy. In our world, that's the algorithm. It is the architect's plan for the house. Now, here's the official textbook definition. An algorithm is a step-by-step procedure for solving a computational problem. And, this is usually where the confusion starts, because you're probably thinking, wait a minute, isn't a program also a set of steps? And yeah, you're right, it is. But here's the critical distinction. An algorithm is the idea, the pure logical plan. It exists completely separate from any specific programming language or computer. It's the strategy, plain and simple. Okay, so let's really break this down. We're going to put them side by side and see just how different they are. And we're sticking with our main analogy here. The algorithm is the blueprint, and the program, that's the finished house. First up, when are they made? An algorithm is born way back in the design phase. This is the thinking part. This is you at a whiteboard or scribbling in a notebook, actually solving the problem. The program, on the other hand, well, that's created during the implementation phase. That's when you finally sit down at the keyboard and translate that clever plan into actual working code. It's planning versus building. And who makes them? This is interesting. The algorithm, the blueprint, is often designed by what we call a domain expert. Think of a scientist who knows the exact mathematical steps to model a weather pattern. They design the logic. The programmer is the builder, the expert in C++ or Python who can take that logic and actually construct the program. Now, sometimes one person does both jobs, but they are absolutely wearing two very different hats. Next, let's talk about the language they speak. An algorithm is written so that we can understand it. We use plain English, flowcharts, maybe some math. The goal is to make the logic crystal clear. But a program? It has to be written in the super strict, unforgiving syntax of a language like C++ or Java, because its audience isn't a person, it's a computer. This leads to a really huge difference between an abstract idea and a concrete thing. An algorithm is universal. The logic for sorting a list of names is the exact same whether you're going to run it on a Mac, a Windows machine, or your phone. It doesn't care. But the program that actually does the sorting is super specific. It's built to run on particular hardware and a specific operating system. The blueprint is portable. The house is stuck right where you built it. So this is the big one. How do we know if they're any good? With a blueprint, an algorithm, we analyze it. We ask questions like, is this an efficient design? How much time will this take? How much memory will it eat up? With the house, the program, we test it. We turn on the lights, flush the toilets, and check for leaks. Does it run? Does it crash? Does it give the right answers? It's two totally different ways of checking quality. Okay, so blueprint, house, I think we've got it. But let's be real. Why does this academic distinction actually matter in the real world? Outside of a classroom? Oh, it matters a ton. When you're in a technical job interview, they don't just want to see if you can type out some code. They want to see how you think. They'll give you a tough problem and expect you to map out the algorithm on a whiteboard first. Same thing goes for competitive exams and programming contests. They are testing your ability to be the architect, because that is the true sign of a great problem solver. And this quote just says it all, doesn't it? The goal is to master the strategy, the algorithm, not just the syntax, the program. Look, learning the syntax of a language is like learning how to properly use a hammer. It's an important skill, for sure, but it doesn't make you an architect. Mastering algorithms is about learning how to design the whole building. It's all about the strategy. All right, for anyone out there studying for an exam, getting ready for an interview, or who just wants the perfect summary to screenshot, this next slide is for you. This is the whole shebang in one neat little package. Let's lock this in. Ready? For phase, it's design versus implementation. For author, domain expert versus programmer. The language, plain English versus a programming language. Dependency, an algorithm is independent, a program is dependent. And finally, evaluation, we analyze an algorithm and we test a program. That is it. the blueprint versus the house. So we firmly established that the algorithm is the all-important blueprint. But this leaves us with a really fascinating final question. I mean, any architect can draw up a plan, but some plans are brilliant and efficient while others are clumsy and wasteful. So how do we actually measure the quality of an algorithm? How do we know if our blueprint is a good one? Well, that's a story for another time.